a brief video to offer a review of power series. If you are uncomfortable with the concepts presented in this video, I encourage you to read in depth the chapter 5.1 that presents power series a bit more slowly and in depth than what I do here. But the assumption is that you should have seen power series in previous courses. So let's look at this. A power series is something in the form sum from n going from 0 to infinity of an x to the n. You want to think about this as an infinitely long Taylor series. So locally, it gives you information about how a function is behaving. We can, when we're playing with power series, we can change the name of the index. So a sum from n equal to 0 to infinity of an xn is equal to the sum from n going from 0 to infinity of am xm. We say that n and m are dummy variables. You can change their name because they get defined when you introduce the sum and disappear when you finish the sum. So while a and x have informations about them outside of the sum that you just defined, the index only exists within the sum. You can shift indices. So, for example, if you have a sum from n equal to 0 to infinity of an x to the n, you can change it into a sum from m equals to k to infinity of a m minus k x at the m minus k. As long as the bounds are correct, you're probably doing it right. You just have to be careful in changing all the indices in the same way. You can sum two power series, and it works in the way you would expect it to work. A power series of an xn plus a power series of bn xn gives you a power series of an plus bn times x to the n. Powers work a little more complicated because you have to do all the cross powers. Think of when you're multiplying 1 plus 2x multiplied by 3 plus 5x. You have all the cross products. You still can do the multiplication. So the multiplication of the power series an xn with bn xn gives you a power series cn x to the n, where cn is all the cross products of bn to b0 and a0 to an. So you have cn equal bn a0 plus bn minus 1 a1 plus all the terms down to b1 an minus 1 plus b0 an. So the index of b is decreasing and the index of a is increasing. Two power series are equal only if and only if all their coefficients are equal. We also say that a power series converges for a certain value of x is if the power series computed at that value of x is less than infinity. We say that a power series has an interval of convergence around its center point. So a power series written as a to the n x minus x naught to the power n has an interval of convergence around x naught of all the points for which the power series converge. And there is a theorem that states that we can bound this interval of convergence. If you compute the limit of the ratio between two consecutive coefficients of x, and you bound that, and you succeed, if the limit is equal to L, then the series converges on the interval x naught minus 1 over L to x naught plus 1 over L, and diverges on the external intervals. Notice that we don't know information about x naught plus or minus 1 over L. That has to be done on a case-by-case basis.